अस्सलाम वालेकुम।
वालेकुम अस्सलाम. हमारा स्कूल स्टार्टिंग फ्रॉम टुमारो.
Tomorrow is Friday.
Sorry, couldn't. What did you say? Tomorrow?
Tomorrow is holiday here.
Acha, tomorrow is holiday. So,
Yes.
when your schools are now starting?
Sunday. In Bahrain, we have Friday and Saturday as holiday.
Oh, acha. Now we were doing we had started electromagnetism. We had started electromagnetism in our last class, and I hope you remember that we had discussed some main topics. We have made a list, and we made an introduction that what is electromagnetism. It is a concept of magnetism due to current. When electric current passes through a conductor, it produces a magnetism. So can you repeat with me? What is the main concept of this chapter? Look at the screen and tell me what is the main concept of this chapter?
Electromagnetism.
So is it something due to current?
Yes.
So what is electromagnetism? Magnetism due
Due
to
to
current.
current.
Look at the one liner of the paper. Sorry, look at the one liner of the chapter. Electromagnetism. What is the one liner? It is the magnetism due to current. So can you repeat again? What is electromagnetism? Hamad, couldn't hear you. Did you say something?
Can't you hear me?
Now I am able. Some issue is coming.
Yes, sir.
So let me repeat and let me try again because some voice was lagging. It is a magnetism. It is a magnetism which is generated due to electric current.
Current.
Electromagnetism is a magnetism due to electric current. Now I'm putting the first concept for today. Electromagnetism. Electromagnetism depends upon the amount of current. It depends upon the direction of current. When you switch off the current or switch on the current or switch off the current, magnetism also disappears. We use iron in this section as a core, and electromagnetism is actually using any conductor for the solenoid. So these are the important properties of electromagnetism. So you have to copy them. If you can hear me, please respond that have you copied it, and also please tell me that you are making all the notes in writing, I hope, right? Because you know
Yes,
the digital form is not good. If you have copied, please inform if you have copied it.
yes, sir, done copy.
So let's again, because this is a very important chapter, and in our O-level physics, it is considered to be a difficult chapter. So can you tell me what is the main concept of this chapter? Can you tell me the main concept? Look at the screen and tell me the main concept.
Main concept is electromagnetism is caused due to current.
Okay. This is a big chapter, and it contains a number of topics. And it contains a number of topics. I'm putting my second concept for today. What are the benefits of electromagnets in comparison to permanent magnets? These can be controlled in terms of the strength of the field and be turned on and off as needed. So
Okay.
just like you press the button and the bell rings, and then you remove the hand from the button, the bell stops. So electromagnetism follow our command. Secondly, you can control it in terms of strength. You can increase the strength, you can decrease the strength. Magnets, electromagnets, some electromagnets are so strong that they can even pick up the containers, and some are so weak that they cannot even pick a needle. So we can control this magnetism completely. Our second concept, electromagnetism is a flexible magnetism, and we can control it as per our need. Can you repeat the second concept for today? What did I say?
Like we can adjust the electromagnetism on our needs.
Very good. This is what I need actually, that you understand something and you write in your own words. So you can increase the volume of your mobile phone, you can increase the brightness, you can increase the temperature of your air conditioner. So basically, it is a control. Electromagnetism is highly controllable. You have to now copy this screen.
Okay.
The name of the chapter is electromagnetism. The name of the chapter is electromagnetism, and this is a challenging chapter. After magnetism, this is a bigger chapter. And normally electromagnetism, electromagnetic induction, these chapters give tough time. Electromagnetism is related with magnetism due to current. So it was discovered that if you bring a magnetic compass, near a current carrying conductor, you will see a deflection.
In 1820, Ørsted discovered that the current passing along a wire deflected a magnetic needle, which indicated that a current produces a magnetic field. In 1820, Ørsted discovered that the current passing along a wire deflected a magnetic needle, which indicated that a current produces a magnetic field.
So, concept comes here. When electric current is passing through a straight wire, circular magnetic field is produced around it. I repeat my concept. The title is here, when current passes through a straight wire, circular magnetic field is produced around it. Now, after giving the heading, please write under it. That when
Okay, I'm looking at it.
electric current passes through a straight conductor, a circular magnetic field around it. You have to copy this screen.
Nine.
Okay, have you done it, Hamad?
No, 7 seconds. Okay. Okay, done.
Good. Now look at the wire. Magnetic field is produced around the wire. This is how magnetic field is produced. When current passes through a straight wire, circular magnetic field is produced. Now, you have to draw this diagram neatly. the circles are having increasing spacing. Hamad, let me know once you have copied it.
Okay, sir. Okay, sir. Done.
Look at this screen. Magnetic field around a straight current carrying conductor. Fleming's right hand grip rule is now entering, because when something is in a circle, it has two possible directions. One is called clockwise and other is called anti-clockwise. Let's make our next concept. When something is in a circle, it has two possible dimensions. It has two possible directions. One is called clockwise and second is called anti-clockwise. So you have to now copy this circle circular directions. Circles, two directions are possible. One is clockwise and second is anti-clockwise. Now, please copy this.
Done.
This is called Fleming's right-hand rule. Look at this rule. This is called Fleming's right-hand rule. The rule says that you have to hold the wire in your right hand. So you have to hold the wire in your right hand and your thumb should be in the direction of current. Then your fingers will be giving the direction of the field. If the current is upward, magnetic field is anti-clockwise. If the current is downward, magnetic field is clockwise. Now you have to give this heading, Fleming's right-hand rule, right-hand grip rule. Please copy this.
That
Okay,
means right hand.
right under it, that hold the wire in your right hand. Hold the wire in your right hand.
Hold the wire in your right hand.
Hold the wire in your right hand such that the fingers are in the direction of current. I'm sorry, such that the thumb such that the thumb is in the direction of current, such that the thumb is in the direction of current.
Hold the wire in right hand such as
The thumb
thumb
is in the
is
direction of current.
is in the direction of current.
Then the folded fingers, then the folded fingers are in the direction of
Current. Then the folded fingers
are
are in the direction of current.
in the direction of magnetic field. The folded fingers are in the direction
Okay.
of magnetic field. This is another way of remembering it. Upward current will produce anti-clockwise field. Downward current produces clockwise field. You have to now copy this. Hamad, let me know if you have copied it.
Yes, sir. Done.
Very good. So, Hamad, can you repeat what is Fleming's right hand grip rule?
Hold the wire in your right hand such as your thumb was in the direction of current, and then the rest four folded fingers should be in the direction of magnetic field, right?
Very good. So it means the folded fingers can tell you the direction. There are two ways to observe something. There are two ways to observe something. One is called front view and second is called top view. Now, this is something related to our vision. When you are sitting in a class and you're looking at the board, when you are sitting in a class and you are looking at the board, you call it front view. But when you are sitting in a class and something falls, you look down on it, it is called top view. So when you open a jar and you want to take out something from the top, it is called top view. So there are two views. One is called front view and second is called top view. You have to copy this screen.
Okay, sir, done.
So there are two types of views.
Front view and top view.
Front view. Front view means something in front of you, just like you're sitting in a car and you are looking forward. It is called front view. Now the
Yeah.
problem comes when we think about top view. Top view means something is coming towards you or something is going away from you. Just like you look at the roof. When you look at the roof, it is called out of the page. When you look on the floor, it is in the page. There are two types of vertical views, but first we come to the front view. Front view means that you are looking and you are looking in the perpendicular axis. You have to copy this.
Done.
No, I have shared, okay, good. I have shared the right hand rule picture on your WhatsApp. So you can look at screen and when you look at this screen, it is the front view. So when you're looking something from the front, it appears like this. It appears like this. There are two options for top view in the page, out of the page. You have to copy this.
Yeah, two options.
So there are
Okay.
there are two types of top views. One is called front view. One is called in the page and the second is called out of the page. And we have two conventions, Hamad. One is called dot and second is the cross. Out of the page, in the page. You have to now copy this. top view. Hamad, look at the screen. Top view means it is coming out of the page and you need to put a dot. You need to put a dot, and this is a very important diagram. These patterns are given in the paper. So you have to copy neatly. You have to copy neatly this diagram. This is top view.
Okay, sir.
So it's like a memory test for you, Hamad. Can you remember we did the right hand rule before also, 1 or 2 class before we did right hand rule also?
Yes, I do remember.
And there was a solenoid.
Solenoid. Yes, wrapped in a wire, I guess.
Yes. There was a solenoid,
Yeah.
and we discussed the idea of solenoid, that solenoids are designed to generate magnetism from electric current. Solenoid are designed to generate magnetism from electric current. I will share with you some, because some animations are needed here, but the time constraint is a problem because I can't play long animations here. Now this is a dot, and you have to see the arrows, okay? And the dot means out of the page. Now, Hamad, have you copied it?
Yes, sir, I'm confident.
Yes, Hamad, please repeat. Have you copied it? Okay. Now I'm putting cross. Cross means in the page. Cross means in the page. And you can look at the screen, the arrows. It means now the arrows are clockwise. It is in the page. Current is in the page. And magnetic field is this shape. If you can hear me, please copy this, Hamad. Hamad,
Okay.
okay, copy it, please. I'm just coming in a minute. Copy it.
Yeah.
Hopefully you have copied it. So I'm putting my next concept. Can you please confirm that have you copied this diagram? Please reply. Hamad, please reply if you are there.
Yes, sir, done.
Okay. Now look at that. Look at the circuit. Electrons are going upward. If electrons are going upward, current is going downward. This is actually a concept we made in our chapters on electric current. When electrons are moving upward in one direction, the current would be in opposite direction. Now we have to copy this. Electric current is conventionally shown from plus to minus.
Yeah, this I know.
Look at this short animation, but it makes a very good concept. Red color beads are showing electrons. Red color beads are showing electrons. And note that if I reverse the current, the magnetic field also reverses.
Found current carrying conductors. Hans Christian Ørsted, a Dutch professor, discovered the magnetic field around a wire carrying current while performing a classroom demonstration of the heating effect of electric currents. He observed that the needle of a nearby compass deflected and the needle returned to its normal position when the current stopped flowing through the wire. He concluded that there is a link between electricity and magnetism. Want to see the deflection? Arrange a battery, ammeter, key, and a copper wire as shown here. Place a magnetic needle below the copper wire. Switch on the key and observe the magnetic needle. Copper wire, reversing key. Let us now trace the magnetic field pattern around a current-carrying straight conductor and a circular coil. Arrange a copper wire, reversing key, rheostat, battery, and a thick sheet of cardboard with a hole at its center as shown here. sprinkle some iron filings on the cardboard. Now, gently tap the cardboard to overcome the force of friction and inertia of the iron filings. Observe that there is no change in the arrangement of iron filings. Now, switch on the current. Observe that the iron filings arrange themselves in concentric circles around the conductor. This is because the electric current produces a magnetic field around the conductor, and the iron filings, being magnetic in nature, align themselves in concentric circles. Place a small magnetic needle in the vicinity of the wire. The direction in which the north pole of the needle points indicates the direction of the magnetic field at that point. Observe the magnetic field pattern when the direction of the current is reversed, and also when the strength of the current is increased. The direction of flow of current is changed by rotating the arm of the key. The needle of the compass deflects in the opposite direction, indicating a change in direction of magnetic lines of force.
Now, we have discussed this concept. Please give a new heading. Experiment to show magnetic field around a current carrying wire. You have to copy this screen. Sorry, I didn't hear you. Did you say something, Amar? Some voice issue is coming up. I'm not receiving your audio. Let me, you can answer. Yes, I can hear you now a bit. Otherwise, you can write on the chat if you have copied the heading. Okay, good. The heading is there, experiment to show magnetic field around a current carrying conductor. Now, I have an apparatus. I have placed magnetic compass on cardboard and I have connected it with a circuit. Presently, the switch is off. Look at the direction of the magnetic compasses. Look at the direction of magnetic compasses. They all are in the direction of earth magnetic field. They all are showing earth magnetic field. Please look at the diagram. No need to copy this diagram because it's the first part of the trial experiment. Now, I have switched on the circuit. Now, look at the diagram. I have switched on the circuit. The compass needles are now aligned. Look at the compass needle before the switch on and after the switch on. You can notice that after the switch on, the circuit is having a current. All the compasses are now in a circular format. all the compasses are in a circular format. This is one direction. This is how this experiment works. After giving the heading, please copy this diagram.
Okay, sir. This cardboard diagram done wrong.
Okay, Hamad, can you tell me when the switch is off, when the switch is off, when the switch is off, the needle, the compasses are in one direction, and when the switch is on, the compasses are aligning each other. The compasses are aligning each other. They follow the current, okay? Now you have to give this new heading. Please copy this heading. Magnetic field of alternating current. This is an alternating current circuit. What is an alternating current? An alternating current reverses its direction again and again. This current does not flow in one direction. So if you construct an alternating current circuit, the compass needle keeps on swinging. The compass needle will keeps on swinging, and current reverses back and forth, back and forth, back and forth. Now, after copying this heading, copy this screen. Hamad, have you made the heading? Have you made the heading? Hamad, please reply. Have you made the heading?
Yes, sir.
Okay, then let's try to complete it in the next class. Let's stop here. We will do it inshallah in the next class.